So this problem, we were given a rod that was hanging from a ceiling, and we were even told that x equals 0 is this point here. We didn't have to be, but you know, cool. And let me just read the question because I forget the question. But it basically told us, well, I remember it enough from doing the problem. It told us that tension 1 is one third of tension 2. And then it basically asks us what is the center of mass of this rod. Okay. Now, if the center of mass of the rod was directly in the center of the rod, then the two tensions would be equal to each other. And just to kind of walk through conceptually, the sum of the two tensions has to be equal to the weight of the rod. That's true no matter what. But if the center of mass is not in the center of the rod, then then the distribution of the tension is going to be different. The rope that is closer to the center of mass is going to experience more tension than the wire that is further from the center of mass. And from that, we already know that the center of mass is somewhere on this side of the rod because we're told that T1 is a third of T2. So T2 has more tension, which means that it's having to take up more of the weight. But again, T1 plus T2 equals the total weight. Now, basically the short of this problem is that the sum of the torques has to be equal to 0 since this is a statics problem. And that's the reason why T1 and T2 are not equal to each other. When we move the center of mass over, no matter how we calculate the torque, one of them is going to have is going to experience is going to need a different amount of force in order to balance the torques. And now the question is, what do we use as our pivot? Now the choice that I made when I solved this was to just make the pivot be x equals 0. So that's what I'm doing here. But what the solution on the exam, the solved exam does, is it makes the pivot be the center of mass. Both of those, in my opinion, are about equally difficult. In other words, one versus the other doesn't make the problem much harder as far as I'm concerned. So it's just a matter of personal choice. So let me work through this one first. So we got the sum of the torques is equal to 0. And now we got to write that out. Well, if I'm making this be my pivot point, what are my two torques? Well, the center of mass itself is exerting a force at a distance, x center of mass. And the force, of course, is just the weight of the rod. So I'm going to write weight of the rod times x center of mass. For whatever reason, I decided to make that the negative torque. And so the other torque is equal and opposite. So I have a positive torque of T over 2 times L, which is just the tension of this rope, which is at a distance L from x equals 0. So one torque is pointing down, the other torque is pointing up. In hindsight, I probably should have made clockwise positive and counterclockwise negative, but it doesn't matter for this problem because they are just equal and they are opposite each other. So one of them just needs to have this minus sign. So I write that out, and now this is my torque equation. This just equals 0. Now, I mentioned that it's also true that the sum of these tensions has to equal the weight, or be equal and opposite to the weight. So if I write out the second equation, which is that the sum of the forces is equal to 0, then I have that negative the weight, which is pointing downward, plus the two tensions, which are pointing upward, equals 0. And so now we have from equation 2 that the weight is equal to the sum of the two tensions, which is something we almost didn't need to write out this step. I told you that this is something that you could just recognize by seeing potentially. Now we're going to substitute in this equation, we're going to substitute this relationship into this equation. So where the WR is, we're going to substitute in T1 plus T2. And so we get negative T1 plus T2 times the x at the center of mass plus T2 times L equals 0. And the problem gives us one extra additional bit of information, which is that T1 equals T2 over 3. So I'm just going to substitute T2 over 3 in here. And now I have an equation that is fully defining the center of mass in terms of T2 and L, which is what I want. And so now I just go through and I solve. So I get negative T2 over 3 plus T2, which is negative 4/3 T2 times x center of mass, plus T2 over L equals 0. The T2's cancel, by the way, and I end up getting that x sub c equals 3/4 L.